My name is Tristan Zhang, and my project is on biochar as a mechanism to influence total dissolved solids and salinity within soil and water. So, what is salinity? Salinity is the amount of salt dissolved in a body of water or the salt content in a soil depending on the medium. While total dissolved solids, or TDS, is similar, but it also counts additional dissolved materials other than salt. Within the city of Fresno, its groundwater averages a total dissolved solid of over 1,000 parts per million, or milligrams per liter, from depths of the surface to 3,500 meters. Well, the EPA recommends a total dissolved solid of 500 parts per million or less for safe drinking water, though 1,000 parts per million has been deemed acceptable if no other water source with a lower total dissolved solid exists. So, is it dangerous or not? Well, yes and no. Consumption of water with over 1,000 parts per million of total dissolved solids can be safe, but it depends on the contents dissolved, such as arsenic and other heavily regulated toxic metals. So, how would we test biochar's effects? Well, my proposed method would focus on the concentration in soil before and after biochar application. The goal would be to create a testable slurry, determine the concentration of total dissolved solids from that slurry, and then potentially determine the ion concentrations as well. What would we get from this? Well, we'd understand the interaction of total dissolved solids alongside biochar. Exactly just how much is interacting with the biochar, being absorbed, and adhering to it chemically. We'd also be able to determine the movement of ions in reaction to biochar. My second proposed method would apply saline irrigation to soil containing biochar. We would test a continuous saline irrigation over a set amount of time, determine the soil concentration following that irrigation, and record interactions between biochar and total dissolved solid. So, why is saline irrigation important? Well, California and the Central Valley pulls a lot of its water from the ground. As we pull more and more, the water eventually becomes more condensed, as such increasing the total amount of dissolved solids and salinity. In the future, if groundwater replenishment rates don't exceed withdrawal rates, then much of the Central Valley would see much greater irrigation with much more saline water. So what would the outcome be? We'd have a greater detail on the application of biochar in a controlled system, which is our lab. We would also gain an understanding of the application on a broader scale. With that, we could come up with a possible solution to helping to mitigate salinity and total dissolved solids within the Central Valley and its agricultural regions. Overall, I hope to work to protect the Central Valley's agriculture, as well as work to prevent pollution as a result of agriculture. And these are my references. Thank you.